Hello everyone, this is Tiago Batista from Coderversity, and in today's video we will learn about RabbitMQ. Today you will learn what is RabbitMQ, RabbitMQ core concepts, RabbitMQ scaling and use cases, and for that we will use practical examples using .NET and C#. So what are we waiting for? Let's dive in. What is RabbitMQ? Let's start with an overview of RabbitMQ. RabbitMQ is an open source message broker that allows systems to communicate asynchronously. When two systems communicate asynchronously, the producer doesn't need to wait for the consumer to be ready to process a message, which makes systems more resilient and scalable. Also, in RabbitMQ, messages are sent from a producer to a queue, and consumers read messages from that queue. However, the message isn't sent directly to the queue. It first goes through an exchange, which decides how to route the message to one or more queues based on routing logic. Let's think of RabbitMQ like a post office. Producers send letters to an exchange, and the exchange delivers those letters to specific mailboxes that are the queues, based on the address, of course, the routing key. So let's start with RabbitMQ core concepts, like queues, exchanges, and routing keys. Let's break down the three fundamental components of RabbitMQ. Like I said, the queues, exchanges, and routing keys. What is a queue? A queue in RabbitMQ is where messages are stored until they are consumed by a consumer. Queues ensure that messages are stored safely, even if the consumer isn't ready to handle them immediately. Queues have some important properties. Persistence, in which messages can be saved to disk to survive server restarts. Durability, where the queue can be made durable, ensuring it persists even after RabbitMQ crashes. They are also exclusive, which means that the queues can be made exclusive to a single connection, and they are deleted once the connection is closed. And also an auto-delete. If no consumers are attached to a queue, RabbitMQ can automatically delete the queue. Now, let's see how you would create the queue in .NET. But first, you need to install the RabbitMQ client NuGet package in your .NET project, like this. For that, let's create a new console project. Console app, RabbitMQ demo. Let's create project and do everything in the program for simplicity's sake. So let's open a terminal. Let's go to the RabbitMQ demo folder and .NET add package RabbitMQ.client. Let's see if this works. Perfect, seems like it's working. Awesome. Now we have the library that we need to use the RabbitMQ. So we'll start by calling the dependency RabbitMQ client, and we will generate a connection. So var factory equals to new connection factory, and then we put the host name localhost. You can simulate this using Docker with a RabbitMQ image. This is just for example purposes. And then we are using a scoped connection which means that after this connection is not used anymore, this using will dispose of this variable and free up the memory and close the connection. So we do factory create connection. Now we create the connection to the local host, and we are going to create a channel as well, a disposable channel, and we'll make create model. Then we will declare a queue. So we go to the channel, queue declare, and we use the optional parameter called queue, and we give it a name like my queue, for example. We can also tell if we want it durable, also to an optional variable, if it's exclusive, if it has an auto delete. Remember that I mentioned all these characteristics before, so if you forgot, just rewind a bit. And the arguments will be no. We will use no arguments. And there we have a declaration of a queue. Now we could do the console.writeLine queue created, for example. In this example, we are creating a queue that is called my queue. The queue is not durable, not exclusive, and will not auto-delete. This setup ensures that the queue remains active until it's manually deleted or RabbitMQ is started. Now, let's go to the exchanges. When a producer sends a message, it doesn't send directly to a queue, it sends to an exchange. The exchange then decides which queue should receive the message. There are 4 main types of exchanges in RabbitMQ. The direct exchange, which routes messages. Actually, let me write this. Direct exchange, which routes messages to queues based on the exact matching of the routing key. Then we also have the fan-out exchange type, in which the exchange broadcasts the message received to all queues attached to the exchange, ignoring the routing key. We also have the topic exchange, which routes messages based on wildcard patterns in the routing key, enabling more flexible routing. And finally, we have the headers exchange, which routes messages based on headers instead of routing keys. So let's declare a direct exchange in .NET using C#. So we access our channel and we use the same type of method. So a declare for exchange, in this case will be exchange declare, in which the exchange name will be let's say my direct exchange, and then the type will be an enumeration, and we will use direct, of course. And for tests' sakes, we console.writeLine direct exchange created. Awesome, so now we have our queue and our exchange. Here we've declared the exchange called myDirectExchange and its type, that is direct, which means it will route messages based on exact routing keys. Now, finally, we have the routing keys. When a producer sends a message, it attaches a routing key to that message. This routing key helps the exchange know where to route the message. In this case, in the direct exchange, the routing key must exactly match the queue's binding key. In a topic exchange, the routing key can follow a pattern to route messages to multiple queues. Here's how you would send a message with a routing key in .NET. So, send a message with routing key, and then let's simulate our message. That will be hello rabbit. Let's show it some respect and put the R uppercase, and let's give it a body that will encode our message, our string, in this case string message, 2 bytes from our message. So here we are sending a message that can be, for example, a JSON where it has multiple information that the consumers or consumer might use to do logic. That is the most popular use. And then we just encoding by getting the bytes out of the message so that it goes in a format that the computer, the exchange can understand. And then we go to our channel and we do a basic publish, which the exchange will be called my direct exchange, that is the one we created. And then our routing key will be called my routing key, and our basic properties will be none, in this case null, and our body will be the body we just created, that is the bytes. And then, as we are already used to, let's send a message to the console that says message sent, and let's use string interpolation just for better readability, which will have our message. That in this case, it's the string. In this case, the message is sent to my direct exchange, and the routing key is my routing key. The exchange will route the message to any queue that is bound to it with a matching key. So let's go to a practical demonstration and combine everything we've learned with a practical example. Imagine you have an e-commerce system where users place orders. When an entire order is placed, we need to log the order and send a confirmation email. We can use RabbitMQ to decouple these two tasks. Here's how we can do that using .NET. Creating queues, like we just did, one for logging, and another for sending emails. So let's change. Actually, let's use another example and create e-commerce example. Let's use RabbitMQ.clients. Let's use the same thing. We'll create again. Yeah, let's create a static class, because this is not a program and this is not the minimal API. So e-commerce example. Let's close it here. And let's call it public static demo. Let's call it demo, not date time offset, a demo in which we will have no arguments, and create this here. Oh, we have to do the return type, of course. That will be void. And then we will create the same connection. And then we'll make use of a channel, and we declare the queue. This way you can do a mental exercise to see if you remember and do if you remember what I'm doing and get there intuitively. It's a good exercise. So in the queue I declare, of course, we do the queue name, and what else? The properties that I talked about before. Of course, if it's durable, if it's exclusive, we don't need any of that for now, just for the example. If it auto deletes, we will set also to false just for the demo, and our arguments will be no. And now we will also do queue declare for our email queue the durable false, exclusive false, the auto delete false, and our arguments null. Now we set up a direct exchange. Let's declare a direct exchange to route messages based on the routing key. So, as we did before, we do go to channel, exchange declare, and we type the exchange name will be task exchange, and we'll make it the type an exchange type direct. And next we have to bind queues to exchange. So we bind the log queue using the routing key log, and the email queue using the routing key email. So let's go again to the channel, queue, bind, and we bind the queue log queue, that is this one. And then we put the exchange as with the name, like we said before, task exchange, And next we put, of course, the last step, the routing key for the logs, for the log queue, the routing key exchange. And we have to do the exact same thing, queue bind. Next, for the email queue, email underscore queue. This has to be the exact same name, so if you want to declare a variable and reuse it, this is just for an example, so don't take it too seriously. And the exchange will be, of course, our task exchange, and our routing key will be email for the emails. Next thing to do is, when an order is placed, send two messages, one for logging and one for email. So what do we have to do? We have to set up a log message saying order placed logging, for example. And then an email message for when an email is sent, order placed send email. Now we have to declare the log body, and of course the log body is an encoding of UTF-8 get bytes from the log message. And we do the same thing for the email body, encoding UTF-8 dot get bytes email message. And next we do a basic publish for both, like we did previously in the program example. So we go to channel and we do basic publish, in which the exchange is, of course, our only exchange, the task exchange, and our routing key for the logs will be log, but you can combine the routing keys with wherever you want. That is your system, you build it like whatever you want. This is just simple for a demo. The basic properties will be null, and our body will be, of course, our log body. Next, we do the exact same thing, a basic publish for our email exchange, email queue, the exchange is the same, task exchange, and the routing key will be email. The basic properties will be null. And what will be the body? Of course, the email body. And as usual, let's do a console.write line messages sent for logging and email. In this example, the log message is routed to the log queue, and the email message is routed to the email queue. This cleanly separates the concerns, allowing both logging and email to function independently. RabbitMQ excels when you need to scale your system. You can have multiple producers and consumers, allowing your system to handle larger loads. For instance, if you have a heavy workload of emails, you can have multiple consumers connected to the email queue to process the message in parallel. And also, RabbitMQ is widely used in different scenarios, such as task queues, like we did here, distributing work across multiple worker services. Message broadcasting, using fan-out exchanges to broadcast events to multiple services. Microservices communication, this is very used in the microservice architecture type, since they are independent and services that work in parallel, allowing services to communicate asynchronously by decoupling them. Basically, the microservice principle. And in this example, you could add more consumers to the log queue or to the email queue as your application scales. RabbitMQ handles message distribution efficiently, ensuring no two consumers handle the same message. And remember, RabbitMQ is a powerful tool that helps build resilient, decoupled systems. Understanding how to use it effectively can make your applications more scalable and reliable. That wraps up our tutorial. I hope you found these projects helpful and that you learned something new along the way. If you followed along, congratulations on completing the project. Don't forget to like this video if you enjoyed it, and consider subscribing to the channel for more programming tutorials and projects. If you have any questions, suggestions, or just want to share your own version of the project, drop a comment below. I'd love to hear from you. Thanks for watching and happy coding. See you in the next video.